Well, it's now February 3rd in the morning, and I'm going to start out by telling a story. I really don't know what you've seen in the video so far, but I'll tell the story at this point. So I took out the IF assembly here, sub-assembly. I put it back in, and I could not get this radio to work. And I spent all day yesterday working on this thing. Come in for 15 minutes, try something I thought up, and leave. And I tried a lot of things on this radio. Injecting signals, looking at signals coming through the radio, spending a huge amount of time with that gigantic manual. And thank you again for those who work so hard to make that manual for people like me to use. I ended the night, must have been 11 o'clock, writing an email to one of you who was also coincidentally got the same radio on their bench. Kind of doing the same stuff to it. And I was lamenting to this person that I'd spent the whole day, and I just suspect that there's something really simple has happened in the radio, but I cannot for the life of me find it. Here's this big beautiful radio dead to the world. And while I'm writing the email, I reached over, and power's off right now. I don't want to turn. Well, it doesn't matter if the power's off. I flipped this knob, and when I flipped it back, I flipped it from AGC with normal operating position. I flipped it to standby, and then I flipped it back, and the radio came to life. 100%. Oh my gosh! All this time, it's this. So I tried it again, flipped it to standby. When I flipped it back, there was no radio. Back and forth, 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 and then one of the times, radio on again. So I'm thinking, what is it? And I think what it is, I think it's the antenna relay that's back in this box. The contact's not making or something like that. And with the antenna not connecting properly, for all I know, staying even grounded, I don't really know. That just silenced the whole radio. So the good news is the radio is working. It's just a particular problem back here. I'm pretty sure this is the where the relay is. In fact, I know it because I can see the relay moving up and down here as the radio operates, and you change switches on the front. This relay snaps in and out. And you first turn the set on, you can hear the relay snap in. And I believe it stays, we're going to have to find this out. I think it stays snapped in until you turn to, you know what, I don't think it, yeah. So I'm trying to figure out this snapped in, oh, my phone, the snapped in, is that the closed on the antenna setting? I should read up a little. I'm going to read up a little on this before I get going here, so I have a little more knowledge in my head, because it's pretty empty on this relay right now. So I'll take a few minutes, read up on this guy, and then we'll figure out what to do about it. It could even involve just bypassing this thing completely. That's possible. Okay, screws are out. This is loose now. It has to slide back a long ways, so I have to disconnect all three of these cables. Now, those relay wires. Pull out my connections here. Oh, that's my shoulder brushing the microphone. Scared the bejesus out of me just now. Okay, out. Out. I want to get access to this far side. Okay, where are we at here? Just lift it up a little more. Get it like that. Wow, that's good. I like that. I can actually freeze it in this position. Oh no, I can't. If I had the right, that's an unusual connector here. If I could snap it on, it would hold it like that. I got other stuff to snap on there. What if I snap this on? I don't know if this is going to hold. little bit crazy here. Yeah, I don't think that's gonna hold anything at all. It's not gonna work. Not gonna work. Okay, don't worry about holding it. Kind of sit like that. Okay, so we're gonna take off these 3 screws here. Screw cup. My screw cup runneth over. What did I do with it? No time to use it. Okay, new screw cup. These come out really easily. That one's missing. Oops. Okay, plate's coming off. There they are. I see the 2 of them in there. Okay, what are we going to do now? Now what are we going to do? Hey, that's the same question twice. So we should, be operating the radio. So first of all, it's completely free. There's no pressure pushing against it. Look at that. A little plastic rod there. So, I need to burnish in there. Burnish, not sandpaper. Burnish. What have I got to burnish it with? I have nothing. I don't have any burnishing tools. I have some. What about the one that's farther up? Yikes. Think about that. So, we do like that. This is a pretty crude way of doing this. And a little pusher. Oh, that stick would be good. Hand me a stick. This one comes with a helper on board. So the objective would be put some pressure on the connection and then pull the paper out, or work the paper. A bit of a black mark there. Same thing there. That could be all it is. Now, to me, it's the far one. It's the far one. That's not so easy. Push a piece of paper all the way in there. Now just go down one. And try to do the same thing with the other one. Well, I got in there. Now I'm going to apply the pressure. Not with this. Not the right tool. Let's try it with this. Yeah, you would never want to use sandpaper in a situation like this. There, I can tell. Oh, did it come out? Frankly, I can't see what I'm doing. Frankly, let's take a look on a close-up camera here. Yeah, right in there on the lower contact. Those contacts, they don't look particularly wonderful either, do they? The like the round, what do they call it? This terminal piece. Whoops. This terminal piece. looks like you could sand that, but I'm not about to. The problem with sandpaper is the grit can be left behind, a little tiny speck of grit. Keep the contacts from mating. They do look bad, I'm surprised. Inside this super duper sealed up thing, I think they look shiny and new. Now, I could abrade those copper terminals with sandpaper, let the non-grit side slide up and down on the contact. But you know, the paper I'm doing this might just be good enough right here. But the difficulty here too will be doing a positive test afterwards to prove that you've done something here without putting the whole thing back together. Only to find out it didn't work. It's just too small for my old eyes to see. I'm just listening to the radio. I don't need the radio on right now. It isn't on. The radio is not on. The radio is off, Jim. Good. That's good. So I got my magnifiers on now. Good. Definitely taking a bit of carbon off it. Try it again. Get it in there, and then I try to push on the pull the paper out. I suppose after 60 years, some of my internal parts might be a little might need a little of work. Not sure what more I can do now. So we could test this with an ohm meter. Come to think of it, no reason to test it in the radio right off the bat. I'll hook up an ohm meter and I won't be able to operate the relay directly, but indirectly. Should be able to do something. So, this is not a hard thing to do. Let's use this meter here. Ohms. What I would want to do then is to connect through the. Oh, that's easier said than done. Put that pin back in, or put this in. So first we'll check this upper reed. Can't put the wire in. Where'd that little pin go? The pin that was in there. What did I do with it? Goodness knows. That's on the end of the wire, isn't it? Yeah, it's right here. It's right here. It's right here. Give me another pin. Give me a new pin. all I want to do is just make contact in there. Think, where's your pins? My pin should be in here. Okay. Let's stick a pin in. There we go. Okay, so that gives me contact to the reed. I'm going to contact over here on the conductor. It's going to be a little tricky. Where's this? Where's this? Okay, so you can see my ohm meter through the mass of wires here. That's a 0. Let's make this a little off. That's what we're hoping to see. 0 ohms. First on the reed itself, 0. Then on the contact, that's interesting, eh? That shows you how dirty this contact is. Now on the actual pin, the through pin, looks good, eh? Let's put it right down to R times 1 ohm. So 1 ohm, well, this is upper scale. I'm not getting up there properly. There we go. Not that I need to make any kind of precise measurement. So this is 100 ohms now, way up here. That's 3 ohms there. Okay, on the reed, 0. On the contact, I have trouble making contact to the contact, 0. And on the pin coming out. So at this point in time, it's fine. I'm going to operate it here. I see it falling to 0 every time. Now, how about the other one? Put the pin in the other. There. Okay, now, are we getting through? Yes. So I'm just going to go straight to the pin here. Right to 0. Okay, we'll operate it. Like 0 every time. Probably should have done this test before I started fooling around with it to prove that that was actually the problem, because you know, either I've cleared the problem by cleaning it, or the problem is something else. Shoot. Okay, so I'm gonna put the plate back on here and put this back in lightly and see if we can see how it works now. So I think the easiest way to try to get that slug to come up where I can get a grip on it is to turn the radio entirely upside down and let gravity try to pull it up, and I can grab it with my fingers. And I think I'm going to have to remove this whole piece here. Let's give that a go. Looks very straightforward to me. With that. 2 washers under that screw. Put that with the mystery ball bearing. So I see these as full of holes here, so you can put your tuning tool down and engage a capacitor down below. That's a locking. It's got a washer and a lock washer. That's what that is. Okay, it just comes up and out. This is a little bit of a spring here, so the alignment doesn't have to be absolutely perfect because it's a carbon rod, and if it's slightly out, a little bit of strain. Okay. So I'm thinking if I turn this over, that rod may slide right out, come right through this hole, and fall on the floor and break. I want that to happen. So I'm going to tape the hole there. I think with a little bit of tape. Because I really have no idea what to expect here. In fact, where's the tape? There it is. If the slug doesn't fall out, what do? Start banging the radio? Make it fall out? Stick or the heat. Let's try some good old black tape here. There we go. Okay. This is an operation. Flipping it over. Let's disconnect stuff. Okay. Got to get this out from under it. You cannot hold this up with one hand. At least I can't. Okay, I'm just going to flip it right over this way. I think that's the way to do it. Holy smokes, it is heavy. I got this stupid thing plugged in, but the power's not on. I would rather not have it plugged in. Heavy enough to cut wires too, these sharp edges. Okay, I'm ready now to tip it right over. I just have to see if it falls out. So I'm just going to have this part of the radio hanging over my bench. That's my plan. It may fall as soon as I do this here. Let's see if I can shuffle this back. Was that it already? No, that's my bench creaking under the weight. Where did that come from? I don't know. Maybe some money's going to fall out. It's probably never been upside down. Like this. Okay, let's go look. How are we going to look here? I'm going to look with this camera. And where is it? Oh, it's already on the floor. Already down here on the floor. Yeah. Okay, let's get a little light on the scene here. Isn't there? Anybody see anything at all? See anything on top of the tape here? Oh, yeah, you can see right through here. Where my finger is. No, there's a bar in the way. If I change bands. These are all spring-loaded, aren't they? There goes one. tape? Oh, it's way back here. Okay, this isn't working out. I gotta look at this a different way. Okay, let's take a look again. There's the tape. There's the slug sitting on top of the tape. It has fallen out. If I take the tape off, it's going to come through. Okay. I'm going to try to pull the tape off. Catch the slug. It is. Wonderful, wonderful. Oh boy, did I ever get away with something there. I will flip the whole radio back up because we're going to put it back together the right side up when the time comes. Oh my gosh, so I built this bench really strong so we could take gigantic radios like this. It's a beast of a bench here. You have beams running across underneath it, 2x4 beams. Okay, bring this forward. Ooh. Okay, it's on the ground now. Let's put the wheels under it. Good. Great. Now, don't lose the slug and the pieces that go with it. Just laying here on my bench. So it's just a matter of epoxying that in there, I would say. Very simple. Okay, let me do that. Okay, just mixing up epoxy. There we are. And it's time for lunch. I'll stick that in when I come back. Okay, lots of time has gone by. Let's see how stiff this stuff is. Still sticky. Not completely solid yet. Looks great. Just leave it. Leave it longer. Okay, lots of time has gone by. Let's drop this back in place here. So I really wonder how long that rod has been broken away. I don't listen to this radio all that much. I'll listen to it more once this is done and I have things set up, but this is not a pleasant radio to operate. It's much more like a technical radio. It's not very good for just tuning around and seeing what's happening. But if you have specific frequencies you're interested in, this is your guy for sure. Oh, that doesn't work. Well, I see it's pretty much at the same height as the rest. That's probably close enough already. I'm getting everything stuck on me here. Let's turn on the radio and see see what happens here. Let's aim for 15. Yeah, it's moving just fine. 15. Right there. 15. Why are we not hearing a thing? Oh, because I disconnected the sound lead. Let's see what we got. Ooh. Ooh. Okay, let's try this. We're not on standby here, are we? Oh, how about an antenna? Volume down. No sound from the radio. You know what? We're right back in that. Right back in this problem. Oh, I heard it very faintly. How do we know for sure what's going on here? We don't. This is quite a headache, this radio. Why does that introduce so much noise? Just putting the ground onto here. Why are we not? Oh. It's just the volume is so low. Is that all it is? Fading out. Well, it's not very strong reception, I think. Interesting enough, the frequency is right on the money, though. That's what I mean. You can, just like any modern digital radio, you can just dial this one right up. Let's see what else we can find here, if anything. $140. Oh, what's happening there? We're grounding out just grounding out the audio there. 140. 770. This radio's not working right. I don't think it's working right. Now there is some strange activity on the sun. Okay, I'll take that back.
With gladly rating when you say "Ikamawera Omo" or "Hello in the ruin." I'm Ruby. After eons of traversing through different lifetimes and planets, our tired soul can finally go home to rest, thanks to the compassionate power of the living
Okay, I'm going to have to face up to another problem on this radio. Excuse me, the whole time. This indicator sits right here. Should be going back and forth with the signal strength. It doesn't. Oh my gosh.
You're listening to Supreme Master Television on International Shortwave Radio via WRMI.
Excuse me.
Thank you for
AGC. No, there's no, what's going on? Oh man, this radio just won't quit. Giving me headaches. Oh, you know, okay, so a lot of, just stupid me, it's just the audio thing shorting out here. Let me fix that. That should stop. Yeah, that's 770. Where'd you go? Oh my gosh. So we're on manual control now.
Satellites across Canada, Mexico, and the United States on Galaxy 19 KU band at 97.0 degrees. Across Australia and New
With the
Zealand on
HEC?
Optus D2 KU band. Across South and Southeast Asia,
Back.
ABS2 Southern Beam KU band.
It's making no difference.
0 degrees east. Across North Africa and the Middle East, Utah at 7.0 degrees west. All now set positions. KU band at 76.5 degrees east. Across Russia areas on Yamal 401 KU band at 90 degrees east. Across the Middle East on Yaset 1 East Beam KU band at 52.5 degrees east. In Sub-Saharan Africa and Europe on Intelsat 20 KU 5 degrees east. In Central and South Americas as well as Mexico on Intelsat 30W6 KU band at 30 degrees west. In Canada, Joy TV on
HEC.
Telus Satellite TV. In Inner Mongolia Autonomous Region, Buryatia, Russia, and throughout Mongolia on D-Dish Satellite TV on Channel 211. Also in Canada, Bell TV Canada, as well as locally on numerous cable and IPTV networks. Please search by postcode at Joy TV. Channel Finder for full channel listings. And Faith TV. Please search by .ca for your
amazing
local
how
channel
sharp
names. Plus in Mongolia, Erdenet, Dakhan, and Ulaanbaatar on Univision Cable TV, and throughout
So it
Lebanon
should
on
be
channel 111 on
15770.
Cablevision. For full frequency information, please visit
Wide open.
suprememastertv.com/satellite. Additionally, Supreme Master Television is available on media streaming television services and regions via Apple TV, LG Smart TV, and Roku Streaming TV in 111 countries, and Amazon Fire TV in 144 countries via Android-based TV
It's
systems
100,
in 198 countries, and Samsung Smart
kilohertz.
TV on
Sorry about
shortwave
all the
radio
coughing
in
here.
Sub-Saharan Africa, Europe, North Africa, and the Middle East on 15770 kilohertz.
Everyone
In
makes a
South and
difference.
Central Americas on 5800
happening over here?
kilohertz. In Central and Eastern United States, plus Canada,
Hey,
Bermuda,
this is working.
Greenland, and Iceland on 9395 kilohertz. In the Western United States, Western Canada, and Mexico on 5950
It's going
kilohertz,
right over the
and in
100
Central,
dB
South,
mark.
Southeast, and Western Asia on 7570
That's
kilohertz,
awesome.
and on podcasts on
The signal is that
Audible.com,
strong.
Google Podcasts, iTunes,
This is
SoundCloud,
probably
Spotify,
the same
and
as the
more.
other radio
Supreme
I
Master
got.
Television
It's
is also
probably
available in
decibels
Argentina,
above 1
San
microphone.
Jose City, La Punta
Doesn't say
City,
that.
and San Luis City on channel 539 on San Luis Cable TV. Throughout Bangladesh on Jago BD TV. In Belize City, Belmopan, Benke, and Kayo District, channel 239, or frequency 291 megahertz on Central TV and Internet. Dan Creek District,
Well,
channel
oddly enough, when
224
you're in
on Southern
AGC,
Cable,
the,
and throughout Belize,
this control is still
TNT
having-
via Southern Cable. Bosnia and Herzegovina on Max TV. In Cambodia, Laos, and Thailand on Melinar. In Cameroon, in Bamenda, Puya, Douala, Kribi, Kumba, Limbe, Tico, and
Little
Yaoundé
loud there,
on
sorry about
Southwest
that.
Communication. In Chile, in Puente Alto, Santiago.
So there is
channel
a
frequency
adjustment in
58.1
here.
on Intercable. In the Democratic
that
Republic of the Congo, in Kinshasa on PSTV. In the
probably
Republic of the
be
Congo
done.
and Central Africa on DRTV, channel 332 and Canal
It's a
Plus.
meter
In
adjustment.
Pointe-Noire, Republic of the Congo on channel 25 or frequency 503.31
lost
megahertz
track
on
of
local TV. In El
Oh,
Salvador
right
on
here.
PC IPTV. And
Carrier
in
meter
Miguel
in
and
game.
Usulután on CableSat. In Guatemala City,
So
channel
there is an
59
alignment
on
procedure
Cable
for
Minerva,
setting this.
and Electronica Chilena
this
in Barberena and Zaragoza,
carrier
channel
meter.
58 on Cable Minerva, and in Esquipulas, channel
dust
1
in there.
on Cable Fácil Digital. In Guyana on Airlink Communications. In India on Airtel DD
Okay,
Direct.
I need to read up on
Dish TV,
how to do
Beeline,
that
and
particular
Tata Sky on
adjustment.
Sadna TV, as well as Geo and all cable networks throughout the Middle East and Greece
Sounds
on
great.
Zap TV. In Nepal and India, Clear TV, Dish Home.
So as I read through all the alignment instructions, there's quite a few places where it says these things really don't ever need to be realigned.
After.
Stop my camera from doing what it's doing now.
I keep talking about it. Maybe
This
you
one
get
is a lot
bored.
different.
You must be
Adjustment,
talking about attending all the time, but I cannot emphasize
adjustment,
it.
gain adjust
Now you know
potentiometer
that. Now you know.
R519.
Especially this new variant, it came from South Africa. And, you know, in England, and now it's everywhere else as well. Many places in the
Correct
world
adjustment of
already.
this control is
This
very
variant.
important. If it is set
We
too
don't know how they
low,
get
the
there. They
receiver
just say,
sensitivity will be below that
virus
required. If it's set
mutated.
too high, receiver noise will be excessive. This
So
adjustment should be
even the
checked once.
government of England, for example, they make
Whenever any two
the variant spread very
the
fast.
RFI of
They
sub-chassis, when two receivers are operated in diversity operation, they need to be balanced. Procedure.
70-80%
Follow this
faster than the
procedure.
usual one. That is the most scary
What?
thing.
Disconnect
People are
P
suffering
from
everywhere
J, P
because
from
they're
J,
suffering.
P
Some
from
people
J,
even
connect
commit suicide.
P
Some
to
children,
J.
they cannot bear it, they die.
Which ones are those? By any chance the antenna?
It's a suffering to no end for other people.
J107.
And things just turn to the better immediately.
No, I don't know. I gotta look
And
at
they
it.
don't do it. My
I
God.
can't just wing this. I gotta find where all these things are.
Parents want to help, but
Yeah.
they
Okay.
must have the
I think it's
condition
worth
to help. We don't create that condition. We have the power.
Hay là mình mời
Okay, step
thầy
one.
Pháp thử
Disconnect
sao?
P114, P213, and P218 from their jacks. That's all three of these. The next step is connect P114 to J513. So what they're really saying is remove the inputs, that's these two, and then take this wire and move it from where it is here over to here, and all you're really doing is connecting this jack on the back
Ông giúp cậu Tuấn con
to
đi không?
the input of the IF. And get it ready for testing so you can feed signals in. This is a standard jack. These are
Để ta nghĩ xem.
little mini special guys. So that's all that is. So I'm going to do that. As much as I don't like filling with these wires. Oh, you know what? I'm going to turn the radio off, I think. Don't have my headphones on. Oh, were you listening to something interesting there? Whoops. Yeah. Grab it, push it, and then turn. Oh, I can't turn it. Okay, this time I'll have room to turn. Grab it. There we go. That should come off. Okay, I guess they just go away. And now this one. And it goes down onto 513. I think it should pre-align the slots here. This is a bit of a different design. I'm not sure I can grab it. This one's actually should be easier. I think I got it right. There. So the whole body can be pushed down. Maybe I can just do it by finger. No. Pulling out the tube is difficult too. There. This is more difficult than one might imagine. I get the two fingernails to push it down and rotate it somehow. I haven't got the best fingernails for this kind of stuff. How will I ever get this off? Ouch. Pull this plug out. All these things I don't like doing. Wow. Oh man, I just whacked my thumb there. Oh boy. It's shocking, but I got it. Okay. Oh, swelling. Okay, this guy's hanging out the back. And there. Wow. Okay. Oh, tube back in. Yeah, we're not going to get anywhere without this. Okay, that's it. That's number one. That's step 1 of 7. Number 2, connect ANURM25. My signal generator happens to be exactly the one they're talking about, URM25. Through adapter 1487. 1487. This may not be the right adapter, but I think I might have one, or I'm not sure what they're talking about here. Or impedance matching network to the IF output jack on the rear panel. So we're going to feed the output of my signal generator into the into this connection here that we just did. Impedance matching network. Uh-oh. So you would think the impedance is 50 ohms back here, and impedance is 50 ohms over there. Why would they want you to use impedance matching network URM25F? I don't know. Okay, so let's connect that signal generator through adapter MX1487. So it's MX1487 URM250 25D. So attach it through this to the output. That's it. So that's all I got to do. Okay, that's easy. I can just. This is my antenna simulator I'm normally having here. Should switch this on. These are all, I've never done this test in any way on this radio before. Okay, this is going to go in the back here. Turn the signal up, down. What does it say about that? Tune it to 455. Adjust the attenuator for an output level of 150 microvolts. Be sure the modulation's turned off. Okay, 150 microvolts. Get a little more serious with this stuff. Usually it's not so critical that these things be set, absolutely precisely, but let's see what I can do here. So the range we're going to be on is 455, so we're going to be on this range. So we want to be in the 300. We want to be on this side. We want to be flipped like that. That turns on this guy. It sets him up for calibration. If I set this to 10. I'm kind of muttering here. That's okay. This has to be up max. 10. So right now, 10 times 1, 10. 10, but they want 150. So 10, that's 100. 150 is a little tricky on this thing. So that's 100. I wonder if it really matters. 100, 150. Be sure the modulation's turned off. Let's just set this to 455. Right there. Okay. $150 microvolts. So it'd be easy, just turn up a little higher, but my meter will go off scale. So what if I set it for it's just a tricky number. You only have so many options here. How do you get to a 15? to do it like this, 10 times. You gotta shrink this guy right back to 15, which would be, it's pretty close to the end of the meter here. Who knows how accurate this is? Oh, it's hair trigger too. Well, yeah. It's jumping around. Is this too close to the edge? This has to be in a different setting anyway, so it's going to throw it off when I... Oh, it didn't move it. Maybe we can do it like this. So that's pretty much 15 on the meter for what it's worth. 15 times 10, 150. Modulation's turned off. Uh-oh. Connect a USM 116 to the front panel diode load jack. Well, there is no front panel diode load jack on this radio, but there's certainly one on the back. And it's the one we're listening to, actually. So we want a voltmeter hooked up onto here. Do like this here. Let's see. A lot of wires all snaking around here. This just has to go here. I think it's positive going. Absolutely nothing there now. The radio's not turned on. That would be a good reason for that. Okay, that's a good thing. If there was something there, we'd be in trouble here. So that's done. Connect the meter to the diode load. Get ready to measure the voltage. Set the receiver controls as instructed in paragraph 552. Turn the function switch to manual gain control. I have to find this 552 and do what it says. Okay, here we go. Line meter off. Line gain 0. AGC medium. Limiter off. Audio response wide. Bandwidth 8. VFO pitch 0. Break-in off. Function set to manual gain control. Antenna trim 0 or whatever is best. BFO off. Dial lock unlocked. 0 adjust disengaged. Dial lock 0 adjust. Local gain 10 or desired volume. The volume is independent. We're not using the audio section of the radio. I'll just leave it down. Yeah, ovens off. It's in the back. They're off. Megacycle change 0.01. Megacycle change. Band number 1 or 1 megahertz band. Wait a minute now. Band number 1. The first band is below a megahertz, isn't it? What did they say here? Check the RF gain 10. RF gain 10. Well, okay, we'll put this down to 1, or as specified. Of course, it depends what the test is. Oh, so what does the test say about that? Does it say anything about that? Because we're just running this part of the radio here. The front part we're not doing anything with. So what would that matter? Set the receiver controls, turn the function switch to manual gain control. That's what that said over there. Loosen the nut and adjust the control for a diode load voltage of minus 7 volts. So we're expecting minus 7 volts. Okay, so a 15 volt scale into my meter. That's it. So it's really, oh wow, the amount of power you're putting into this thing is really, really important for this. I mean, if what I'm putting in is different from what it's supposed to be, if it's not 150 microvolts, 150 is very difficult. Is there some way I can measure the 150 microvolts? I think I have meters that'll work at that frequency. It's only 500 kilocycles. Or yeah, you know what? I think it's worthwhile trying to measure the voltage coming out of my signal generator. I'm going to stop for a bit and do a couple experiments here. Okay, here we go. Line meter off. Line gain 0. AGC medium. Limiter off. Audio response wide. Bandwidth 8. VFO pitch 0. Break-in off. Function set to manual gain control. Antenna trim 0 or whatever is best. BFO off. Dial lock unlocked. 0 adjust disengaged. Dial lock 0 adjust. Local gain 10 or desired volume. The volume is independent. We're not using the audio section of the radio. I'll just leave it down. Yeah, ovens off. It's in the back. They're off. Megacycle change 0.01 megacycle change. Band number 1 or 1 megahertz band. Wait a minute now. Band number 1. The first band is below a megahertz, isn't it? What did they say here? Check the RF gain 10. RF gain 10. Well, okay, we'll put this down to 1, or as specified. Of course, it depends what the test is. Oh, so what does the test say about that? Does it say anything about that? Because we're just running this part of the radio here. The front part we're not doing anything with. So what would that matter? Set the receiver controls, turn the function switch to manual gain control. That's what that said over there. Loosen the nut and adjust the control for a diode load voltage of minus 7 volts. So we're expecting minus 7 volts. Okay, so a 15 volt scale into my meter. That's it. So it's really, oh wow, the amount of power you're putting into this thing is really, really important for this. I mean, if what I'm putting in is different from what it's supposed to be, if it's not 150 microvolts, 150 is very difficult. Is there some way I can measure the 150 microvolts? I think I have meters that'll work at that frequency. It's only 500 kilocycles. Or yeah, you know what? I think it's worthwhile trying to measure the voltage coming out of my signal generator. I'm going to stop for a bit and do a couple experiments here. Okay, I've set this now to 15. It's as good as it's going to get. ready to start things up here. Where are we? Oh, keep reading, keep reading. Loosen the hexagonal nut on the gain adjust control and adjust the control for a diode voltage of -7. So we're not going to loosen the nut until we see -7 coming up on this meter here after I turn on the radio. How about like that? On. Now we disconnected the whole front end of the radio. We're just feeding a signal right into the IF, so it's going to come out the sound here. Let's see what we're hearing, if anything. Don't know what to expect here. No, it's an unmodulated signal. So it's really kind of what shows up on here. Ah, this is bad. Really too many wires all jumbled up here. Nothing showing up here at all. Actually a positive voltage. So, gee, we have this thing reconfigured now. Who knows? Did we do it all right? Did I not follow a step? Loosen the nut. Adjust. Tighten the nut. I'm the nut that's been let loose in here. So why nothing on here? 15 volt scale, DC minus, negative voltage should put it upscale. We're clipped on to just going to kill the sound. We're not supposed to hear anything anyway. Well, that's not really true, is it? Oh, you know what I should do? I should put the, I'm going to put a modulated signal on there until we get things going. Because for all I know, this radio could be so quiet. Okay, volumes are down. Modulation. It should be a tone. What do we hear? Not a thing. Not a thing. Radio's running with 112 volts, which is okay. So what has not worked out here? See, no voltage. Oh, no, the antenna relay should have no effect. I was just going to say this antenna relay thing. No, that's all fixed up too. Up full. No, she's broke. I got it. Like it just says, get a voltage reading of 7 volts. You've got to imagine it's normally right around 7 volts. I think it's a strange thing in this document. There's a little pen icon there, and it says 1 volt DC. Maybe plus or minus? Is that what they were trying to put there? That's probably what happened. They're probably trying to put a plus or minus there. Okay, so how now did I get the right cable plugged in to the right socket, or did I hook it up to the antenna? No, it's hooked up to here. The signal should be coming in here. Going down there. Okay, I do have the modulation on now. What could it be? Almost anything. VFO off, isn't it? It was VFO. Did they say in here turn the VFO on? Tune to 455 and adjust the attenuator for an output. Now I've got it set to 455, but you know, I may not be on 455. Maybe I have to let's broaden this out and move the frequency around. Let's just check it here. Take it off calibration. Okay, can't be that far out. So in my normal operation, this is a very, very small signal. Should I just heft it up? Maybe I've done this calculation completely wrong. It is low. It is low. I've got it 1 times. Yeah, I left it where it was. This should be up 10. Okay, so that's about, well, it could be 5,000. 6 times 10. No, it's only 60. Oh my gosh. Hello. Hello. Come in, Jim. Come in. Shop to Jim. Shop to Jim. Okay, so now we're putting in 600. Putting in 600, not 150. I knock this back now. Take the tone out. Did we get a voltage? We have a little voltage over yonder. Let me put the tone back. Makes no difference. So without the tone, because when I flip this over the tone, the function of the meter changes. So over here is where the meter reads RF. You know, it's still very close to. Let me do this. You can hear the frequency shifting slightly. It's a bit of a fine adjustment here. Okay, so that should be that's 150 on this meter for whatever it's worth. And it's coming through. Okay, now look at the meter over here. I think I shouldn't make the adjustment of anything until I tune so that that meter is as high as possible. Let me just tune the signal generator now. Oh, it was. That's it right there. That voltage is supposed to be -7. And look at it. So we're on the 15 volt scale. It's 1 volt. What was that other note that said 1 volt? Well, we'll try adjusting this thing and see what happens. You know, on another matter, I'm unsure now of what I'm going to have posted or not posted. This is not the original tube. It's a substitution tube, and its function, I believe, is made weak in this radio. It's not really the best tube to have in here. That could be weakening the whole deal. Never known this radio to be weak, though. It's always competed right on the money with gain, carrier meter, gain. Okay, this isn't all that tight. And the concept is make that meter, that one. So 7 is there. How do you like that, eh? I think this radio just got a super boost. Okay, I'm checking the output is it's at 150 microvolts. We're up at 7, minus 7, plus or minus a volt. And I'm going to vary the signal over here a little bit to see how sensitive this is. So that's 100. That's 150. It's reproducible. And that's 200. Yeah, that's pretty good. I got pretty good. Well, is it? We really don't know what the output of the meter is, but I think the radios, I think that's a great improvement. Surely to goodness it was way too low. No, it's much, much, much better. I think. Okay, and the last step is put everything back to normal. Okay. No, that'll be a challenge. You know, everything back to normal. Here's a last test of sensitivity. So I'm just doing it at 9,500. The signal generator is attached to the antenna. Signal generator is calibrated. Ten microvolts times 0.1 is 1 microvolt. This is 1 microvolt on this radio. And we can take it down here. Let's just stuff in front of the camera like that. Just that's about as weak a signal as you could ever kind of realize is there. How strong is it? That's 4 times 0.1. 0.4. 0.4 microvolts. Back up to 1. 1 microvolt. Oh, that's really, really good. I think that's pretty good. Okay, got the radio back together, ready to switch it on. Here, I get my headphones on. There we go. So what I want to do is basically it's correct this problem with this meter here. Pretty sure the next adjustment will correct it.
Like a roller coaster. Our feelings go up, they go down. Our feelings are deceptive. We may feel very good about something, but the reality is that according to God's word, it's actually very wrong.
Okay, so
And sometimes it's just the opposite. We may not feel so good about something, but yet we follow through in faith, and it comes out to be the best thing that we can do.
this control all the way this way. The meter should be zeroed. And I think I'm going to adjust it. It's just this one here. Whoa. Oh, it's a hair trigger, this thing. Wow. Oh, smokes. 0 reading. Okay. Oops, went up a little bit. It's so hair triggery that. Oh, yeah, whoa. I'm rolling the plane over. Hold on. Yeah, put your seatbelts on. Ooh, that's pretty good, eh? It's gone way below now. Son of a gun.
A fallen mountain. Scripture also speaks of depression as a
Wow,
broken
that makes some
spirit.
sense.
It's spoken of as being sad. It's spoken of as being burdened by the weight of sin. It's spoken of as experiencing or having grief. It's spoken of as mourning. It's also spoken of